Hello everyone and welcome back. Today's lesson, Lesson 5, Exponents. Student outcomes. Students discovered that 3x equals x plus x plus x is not the same thing as x to the third power, which is x times x times x. Students understand that a base number can be represented with a positive whole number, positive fraction, or positive decimal, and that for any number, a, we define a to the m power to be the product of m factors of a. The number a is the base, and m is called the exponent, or the power of a. So here's three expressions that I'm going to have you evaluate. So take a moment, pause the video, solve each expression, and pay attention to how you came up with the answer. So again, did you think about how you came up with the answer? Most of you probably saw this, and you saw that I have 10 groups of 4, so 10 times 4 is 40. Here I have 5 groups of 9. 5 times 9 is 45. And for the last one, I have 5 groups of 10, which is 50. So naturally, you took a shortcut. A few of you may have even added on until you added 4 all the way up to 40. Of course, that second method, there's a pretty good chance you could make a mistake because you're adding so many 4s, and 10 times 4 is much easier. So multiplication is a faster way to add numbers when the addends are the same. When we add 5 groups of 10, we use the abbreviation and a different notation called multiplication. So 10 plus 10 5 times is equal to 5 times 10. If multiplication is a more efficient way to represent addition problems involving repeated addition of the same addend, do you think there might be a more efficient way to represent the repeated multiplication of the same number or same factor, as in 10 times 10 times 10 times 10 times 10? Of course, if you said yes, you are absolutely correct. Here we have our 10 times 10 5 times, and here is a much shorter, easier way to represent that information. So we have 10 to the 5th power. We see that when we add 5 groups of 10, we write 5 times 10 in adding, but when we multiply 5 copies of 10, we can write about 10 to the 5th power. So multiplication by 5 in the context of addition corresponds exactly to the exponent 5 in the context of multiplication. So here we have our exponential form. We have 10 to the 5th power. The whole number is our whole number. The number 5 is called an exponent here, and it's written in what we call superscript. And superscript is basically halfway up the number, and the size of the number is half the size of the original number. So here's some examples 1 through 5. Go ahead, take a moment, pause the video, and come back when you're ready. But basically for this, if it's written in repeated multiplication, you're looking for something with an exponent. And if it's written in exponential form, you're going to be looking for repeated addition. Again, take a moment, pause the video, and come back when you're ready. So how'd you do? Here's our answers. Just take a moment, 5 to the 5th power, because we're multiplying 5 together 5 times, and so on down the line. And when you came up to exponential form, you had to show the repeated multiplication. And obviously on the last one, g to the 3rd power is g times g times g. So if you made any mistakes, go ahead and take a moment and correct those. Taking a closer look at the difference between 3g and g to the 3rd power, well, 3g is basically 3 times g, whereas g to the 3rd power is g times g times g. So looking back at our examples 1 through 4, grab your calculator out and take a few moments to solve, and we'll do the first one together. So the first one says 5 to the 5th power. So you can see I have it 5 times, 1, 2, 3, 4, 5. I hit my equals button, and I end up with 3,125. So again, grab a calculator and go ahead and solve the remainder 2, 3, and 4 on your own, and come back when you're ready. So here's our answers, pretty self-explanatory. The last 3 here. If for some reason you have a different answer, no big deal. Grab your calculator and try it again. Moving right along, example 6, we have 3 8/10 to the 4th power. So again, we're going to pause the video and see if you can come up with an answer by using your calculator. So here's what it looks like. We have 3 to the 8th, or excuse me, 3 8/10 multiplied by itself 4 times, and our final answer, which I ran out of room, is right there. Similar on number 7, example 7, except for this time we're showing the repeated multiplication, so please represent it in some type of exponential form and then solve. Come back when you're ready. Here we see our exponential form, 2 1/10 to the second power, and when we multiply them together, we have our product there. Example 8, I've gone ahead and done some of the work for you. So we have 0 and 75/100s 1, 2, 3 times, so it's to the third power. And by the way, to the third power, if a number's to the third power, we can say 3 cubed, and when it's to the second power, we can say 3 squared. So basically 3 squared is when you multiply 3 times 3, and 3 cubed comes from the idea of a cube. As you can see here, 3 times 3 times 3, you get that cube shape. On 9 and 10, we're going to work a little bit with fractions. It really kind of works the same way. If we have it as repeated multiplication, rewrite it as exponential form. And if you have it in exponential form, you can rewrite it as repeated multiplication. And pause the video, go ahead, take a few moments to solve. This time you will not be able to use your calculator, but it's not very difficult. Come back when you're ready. So we can see here we had 1/2 times 1/2, which is 1/4, and then 1/4 times 1/2 gives us that 1/8, and it was 1/2 to the third power. Here's our repeated multiplication, and we get 4/9. And notice it's a little bit different than the first one. So when we had, for example, 3 to the third power, that's 3 times 3 times 3, that equals 27, and the answer got bigger, our product got bigger. Here we have half times half times half, and we end up with a smaller number than what we started with. So here's a chart of information. You'll take a few moments to use your calculator to figure out the final column if you need it, and only on the ones that you can use it. But the first row has been done for you. 3 to the second power is 3 times 3, which of course in standard form is 9. So again, take a few minutes, pause the video, and come back when you're ready. So here's our answers. Again, carefully look over your work, see if you can find any mistakes. If not, go on. If you find a mistake, feel free to correct it, or just try your work again to see if you can come up with the right answer. On the home stretch here, 2, 3, and 4, again, slowly read through them, see if you can solve them, and then pause the video, solve them, and come back when you're ready. So for our first one, we have the exponential form, we have repeated multiplication, and we have our standard form. Same thing here. I did write it in parentheses, just cleans it up a little bit, but it means the same thing. When you see squared, which we mentioned before, it's to the second power, and when you see cubed, it's to the third power there. Little side note, repeated multiplication, and our product. And on this last one, this student thought that 2 to the third power was 6. As you can see here. So he or she was probably thinking either 2 times 3 equals 6, or maybe off on the right hand side here, maybe he just added those numbers by accident, 2 plus 2 plus 2, or maybe he really added those numbers, 2 plus 2 plus 2, which gave him 6. At any rate, his answer is incorrect, and I would fix it by showing the repeated multiplication. 2 times 2 is 4, times 2 is your 8. Great job on today's lesson related to exponents. When you're done, feel free to go back and watch the video again. Otherwise, go ahead and complete your exit ticket and bring it to me when you're ready. Fantastic job.